Now, next one is dipole induced dipole interactions or Debye forces. Match the following questions can be asked regarding each one. Here also, Keystone forces. That is also match the following. Dipole interaction, Keystone forces. Dipole induced dipole is known as Debye forces. Sometimes a polar molecule having a permanent dipole distorts a normal non-polar molecule and induces a dipole moment in it. The forces developed due to the interaction between a dipole and an induced dipole are called Debye forces. Debye forces come into existence when polar molecule is brought closer to the non-polar molecule. I told you if a permanent dipole molecule is there which approaches a neutral molecule, by the presence of this permanent dipole effect, this neutral molecule can also be converted into a dipole by induced dipole interaction. The positive end of the polar molecule attracts the mobile electrons of the non-polar molecules, distorts it and changes into induced dipole. The reason how a neutral molecule can be converted into an induced dipole, how? Because there are mobile electrons are there. These electrons are negatively charged particle. These negatively charged particles are attracted by the positive end of the permanent dipole. As a result, the negative charge is slowly shifted within the molecule to one side which is closer to this positive side. Thereby, this end is considered as negative and the other end is positive. The positive end of the permanent dipole molecule can now attract the displaced electron cloud. This is the electron cloud of the induced dipole, and the two are held together by an electrostatic attraction. Debye forces are not affected by temperature. Fill in the blank question. It is not affected by the temperature. However, they depend upon the distance between the dipole and the induced dipole. They have nothing to do with the temperature, but the distance is very important. If it is very far, this positive part cannot attract any electron. Therefore, as the distance decreases, the inducing capacity of the permanent dipole also increases. Third point, ion dipole interaction. The ion dipole interactions involve the attraction between an ion and a polar molecule. The strength of an ion dipole interaction depends upon the charge and the size of the ion and also the magnitude of the dipole moment. Fill in the blank questions. And the size of the polar molecule. Since the charge density on cation is higher than compared to that on anions, cations attract a dipole more strongly than an anion having the same charge but bigger size. Fill in the blank question. See, since the charge density on cations is higher as compared to the anions, cations attract a dipole more strongly. That means cations are capable of attracting the ions more strongly than an anion having the same charge but bigger size. The hydration of ions is due to this type of interaction when an ionic compound is dissolved in water. The ions attract water molecules which have a larger dipole moment and gets hydrated. Thus, water molecules act as a dielectric to keep the ions apart. The non-polar molecules such as carbon tetrachloride act as a poor solvent for ionic compound because they are unable to participate in ion dipole interaction. That means if ionic compounds means they are having positive and negative charge. In water there are H plus ions and OH minus ions. Because of the presence of these ions, always there is an attraction between the positive ions and the negative ions between these ions. That is why we consider that ionic compounds are dissolving in water, because of they are in close contact with these ions and they get immersed in between these ions. Whereas in non-polar solvents there is no positive and negative ions like that. The compound which is remaining will remain as such, because there is no question of any positive or negative ions as in water. In non-polar solvents like carbon tetrachloride or anything.